Hello everyone. In this session, I would like to share with you another example on a second order non-homogeneous linear differential equation with constant coefficient. Okay, let's look at the example. Solve the y double prime plus y prime equal to 2 sine x by using the method of undetermined coefficient. First of all, if you look at this question, you know that this is non-homogeneous. This is because this fx is equal to 2 sine x, which is not equal to 0. So in this session, I will teach you using the method of undetermined coefficient. So first of all, you need to find the complementary equation, which is the YC. So step 1, find the YC. So find the YC means that you treat this equation as a homogeneous first. So y double prime plus y equal to 2 sine x. So this is the equation. Then I assume y double prime equal to m, and then y is 1 equal to 0. Okay, equal to 0 because you assume it's a homogeneous first. Then you factorize it, so to get the root value. So m squared equal to minus 1. So this is equal to plus minus I because of the imaginary. Minus 1 is a imaginary when you square it. So your m is plus minus I. So from the table, okay, you still remember the table? That is the root is plus minus I. So what is the case? It's a complex number case. It's case. If it's complex numbers, that is case number 3. You have the exponent alpha x, a cos beta x plus b sin beta x. So your alpha value, your alpha and beta. So this is alpha plus beta I. Okay, alpha is a real, beta is a imaginary. Since this the answer for the m, the root is just the imaginary. So alpha you will get 0 and beta is referred to the I here. The I here is referred to 1 only, so you will just get 1. Okay, so this is your YC. So next, you need to find the YP. So YP, you need to assume. So YP is based on the question, that is the fx. So in your case, your fx is 2 sine x. Okay, this is from the question. 2 sine x is your the fx value. So this is the case of trigonometry. Okay, so you need to assume your YP. You still remember the table of YP? So this is the table of assume the YP. For trigonometry, you have this one, sin, sine, and cos. So yours is sine. So that one is YP equal to C cos n x plus D sine n x. So C cos nx, n you can tap back. Okay, n here is just 1x, so you just put back that one. And also here, sin x also is 1x only, sin 1x, so you get 1x also. Then you check whether the YP, okay, you get the YP here, you check whether this YP is same as YC or not. YP same or not with YC. If you look at here, C cos x, A cos x, so this is the same. D sine x, B sine x, so this is the same. So YP same with the YC, so cannot. So what you have to do, if cannot, if YC is same to YP same to YC, you cannot continue. So you need to multiply the x with the YP. Okay, so your YP is CX cos x plus DX sine x. So you check again, is YP and together with the YC, same or not? Here is CX cos x, here is A cos x, so it's not the same. This one also not the same, so YP not the same with YC. So now if not the same, this means that that is your lattice YP. Okay, and then step number 3, you need to find the YP prime and YP double prime. Okay, you need to find from the using the lattice YP. So YP prime equal to, based on this YP, lattice YP. So you assume this is as a U and this is as V. Okay, so U equal to CX, du dx equal to C, and V equal to cos x, dv dx equal to, you differentiate, you get negative sine x. So you use the formula, product formula, u v prime plus v u prime. So you get u cx, v prime, you get negative sine x. And then plus with v is cos x, u prime, you get c. Okay, you get c. So this is for the first part only. What about the second part? You also do the same thing. So I write down here for the second part, yp prime equal to cx negative sine x plus c cos x, and then plus with this one, if assume is u and v, so u you get dx, v prime you get cos, plus v you get sine, ux, u prime. Okay, v u prime you get d, so you get d sine x. So this is your y prime. Then what about yp double prime? You differentiate the yp prime, you get yp double prime. So the method is the same. So you can assume this one is p and then this one is q. Okay, so p you get cx, and then q you get negative sine x. So differentiate the p, you get p prime, so you get c. Q equal to negative sine x, you differentiate, you get negative cos x. So here you get uv prime plus vu prime. You will get here is p is negative cos x, q prime, p is cx, q prime is negative cos x, plus q p prime c. And then you differentiate the c cos cx, you differentiate cos, you get negative sine, negative c sine x. And then you differentiate for this part again, the same method. So I get plus dx, negative sine x, plus cos x d. Okay, and then for last part, beta sign, you get cos, so d cos x. Okay, that is the y prime and y double prime. Now you get to substitute everything in the equation. So for y double prime plus y equal to 2 sine x. Now you copy down or substitute the y double prime. So y double prime is cx negative cos x minus c sine x minus c sine x plus dx negative sine x plus cos cos x d, then plus d cos x plus cx cos x plus dx sine x, then equal to 2 sine x. Okay, so this front one, the first one is the y double prime. Okay, this one is y double prime, and this one is y. Okay, this one is y. The first one is y double prime. Okay, so now you can compare the coefficient. You can compare the coefficient. So you compare to 2 sine x. So in this equation, okay, this is cos, this is sine, okay, this is sine, this is also sine but with x sine x. Okay, this is cos, this is cos, this is x sine. So we only have this is sine x. So you have negative c, so negative 2c, negative 2c. So now we compare with the sine x, okay? So we compare, maybe I can say like this, okay, compare coefficient of sine x, okay, compare coefficient of sine x. So now you have negative 2c for the left hand side, and the right hand side you have 2, okay, you have 2 here. So negative 2c equal to c equal to negative 1. Then what about d? For the cos x, if we compare the cos x, we have nothing. Okay, if we compare coefficient of cos x, we only have d, 2d, but right hand side don't have anything. So we said 2d equal to 0 and d equal to 0. So now we can get the value of c and d. So therefore we say that yp equal, if we check back what is the yx, right, yp, right? So the letters yp. So the letters yp is cx cos x plus dx sin x. So cx cos x plus dx sin x equal to c is negative 1, so negative x cos x. Now you can write down your general solution, y equal to yc plus yp equal to a cos x plus b sin x minus x cos x. Okay, you combine the YC plus YP. So this is the YC and this is the YP. Okay, that's all. That's all for the second order non-homogeneous using the undetermined coefficient method. Thank you for watching.